Most of you in high school probably learned the sine and cosine functions by using a right triangle. And that's fine. But another way to define the sine and cosine functions is by using a different graph. We're going to use the unit circle. Let me write the equation here. This is the unit circle. X squared plus y squared equals 1. We're going to use that unit circle to determine the values of sine and cosine. So here's how we do it. We're going to look at the x-axis as being the initial side of an angle theta, and let's say theta is positive. If theta is a positive angle, usually measured in radians, we're going to go in this direction, theta radians, and stop. Okay, so there's theta. This is called the terminal side of the angle, and the x-axis, or what we consider the x-axis if we're looking at it as a unit circle, is this line right here. So there's our angle theta. Now, whatever you can see that no matter what value of theta I give you, if theta is positive, we go counterclockwise. If theta is negative, we go clockwise. We have a particular stopping place, and there's only one terminal side, and it's going to intersect the unit circle at some point. This point has x-coordinate cosine theta and y-coordinate sine theta. Now, defining it this way, can you see why cosine squared plus sine squared is 1? Well, because x is cosine squared and y is sine squared. So for any angle, the cosine theta sine theta is a point on the unit circle. So let's see. There are certain values of theta that are very easy to calculate what the coordinates of those points are. And these are all the multiples of pi over 4, all the multiples of pi over 6, and the multiples of pi over 2. So before I show you how to do it, it's really easy. All you need to know is two types of triangles. So let me give you one will be a 45-45 with hypotenuse 1. So this is 45-45, or pi over 4 angle. Pi over 4 for theta, radius 1. All you need to know is the length of the sides of this triangle. This forms a right triangle, and this would be the square root of 2 over 2 and the square root of 2 over 2. Notice the Pythagorean theorem is satisfied. If you square square root of 2 over 2, you get 2/4 plus 2/4 is 4/4 or 1. So that little triangle in your toolbox, knowing it, and then one more with hypotenuse 1. We want this to be a 30-60. In other words, this is pi over 6 for theta, and this is pi over 3. That angle would be pi over 3 with a hypotenuse of 1. In that case, the short side is 1/2 and the long side is the square root of 3 over 2. Now if you just look at those for a minute, put it on pause, write them down on a piece of paper or something. I'm going to show you how you can use those two triangles, those two little right triangles, to compute all of the sines and cosines that you need to know in a calculus class, really, unless you're using a calculator. Okay, first of all, sorry my drawing is so bad there. The yellow circle is the unit circle, and if we know that 90 degrees is pi over 2, and 180 degrees is pi, and 270 is 3 pi over 2, and this is 0 degrees, or you could go around once and say 2 pi radians. So those are the multiples of pi over 2, multiples of 90 degrees. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Now let's cut those angles in half and we have the pi over 4s. Pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and back to 8 pi over 4 or 2 pi. So these are the first angles that are very easy for you to determine the sine and cosine of these angles. Let's see, let's do our points. Well, first of all, let's do the multiples of pi over 2. This point right here has coordinate 0, 1. You're thinking on the unit circle now. X equals 0, y equals 1. This point has x coordinate minus 1 comma 0. Down here, the negative y-axis, we're thinking of now x squared plus y squared equals 1. That has coordinate 0, negative 1. And of course here at theta equals 0 or theta equals 2 pi, we are at the point on the unit circle 1 comma 0. Now for the multiples of pi over 4 that are not on the axes, every single one, if you drop a perpendicular to the x-axis in order to get the y and the x coordinate, well, y is the square root of 2 over 2, x is the square root of 2 over 2 because they're all 45, 45 or pi over 4 triangles. So look, let's just take this one right here. This point, if you drop a perpendicular down to the x-axis, that gives you the y-coordinate, and the x-coordinate, it's a 45, 45. So the coordinates of this point are the square root of 2 over 2, square root of 2 over 2. So that's 1 pi over, and all of these give you 45, 45s. So you can see, like, let's find the sine of 5 pi over 4. The sine of 5 pi over 4. Well, I just count around here. I know I have 1, 2, 3, 4. Here's 5 pi over 4. I just need the y-coordinate of that point. Well, if I drop a perpendicular to the x-axis, they're always, all these odd multiples of pi over 4 are going to give me 45, 45. So the sine and the cosine are going to be either plus or minus the square root of 2 over 2. The y-coordinate in quadrant 3 is negative, so the sine is minus the square root of 2 over 2. That would be the y-coordinate of this point right here. So let's try one more with these, or a couple more. Let's try the cosine of, how about the cosine of minus pi over 4? Okay, so I know it's a multiple of pi over 4, and it's going to be square root of 2, square over 2, square root of 2 over 2, but I have to see exactly where it is, so I always just draw myself a little axis, and I go this way because it is negative 1 pi over 4, so that is going to give me a point in quadrant 4, one of the 45, 45s. Cosine is the x-coordinate, x is positive, square root of 2 over 2. How about the sine of 11 pi over 4? Well, I'll just go to draw myself a little thing here, and I'm just going to count around pi over 4. Going to go this way, and I'm going to do 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right here. And my x is negative, my y is positive. I want y because it's sine, so it's square root of 2 over 2. There I went around the circle more than once, but I know that the pi over 4s, I know exactly what they are. I just count around, and even, I mean, to this day, I still don't have these things memorized. I just know that the odd multiples of pi over 4 are always going to land me on a point on the unit circle where if I drop the perpendicular I have a 45, 45. I just have to figure out which quadrant it's in. So I know if x is negative or positive, y is negative or positive. And of course if it's an even multiple of pi over 4, like let's say, let's find the cosine of 3 pi. Well, then I'm just going to go around. I could go around in jumps of pi. 1 pi, 2 pi, 3 pi puts me right here. Do that again. Going this way, it's positive angle. 1 pi, 2 pi, 3 pi. The x-coordinate is -1. Let's do one more. How about the sine of minus pi over 2? Well, the pi over 2's are 90 degrees. And I'm going in this case, excuse me, I'm running out of room here. Let's go over here. I just draw my little x and y axis. Minus pi over 2, that's 90 degrees, and I'm going this way. So I land right here. And I'm looking for my y-coordinate. It is -1. So the sine of minus pi over 2 is -1. It's that easy. This is all you need to know for all the multiples of pi over 2, odd multiples of pi over 4. Just know the x and y coordinates on the axes, and for 45, 45 triangles to use this here you have to memorize, and the definition of sine and cosine using the unit circle. Okay, so the only other angles that's handy to know are the angles that are multiples of pi over 6, which gives us, of course, pi over 6. That's a third of 90 degrees, isn't it? So it's right here. That's pi over 6. 2 pi over 6 is 2 of those. Well, that's pi over 3. 2 pi over 6. 3 pi over 6, well, there we are at pi over 2. 4 pi over 6. 5 pi over 6. This is 4 pi. Oh, I should put 2 pi over 3, simplify it. 4 pi over 6. 5 pi over 6. 6 pi over 6 is pi. And then we have 7 pi over 6. 8 pi over 6. 9 pi over 6. 3 pi over 2, and we have these. So dividing the 90-degree angles into thirds gives us 30-degree angles, or pi over 6, and pi over 3 is 60 degrees. Now in each one of these, no matter where, if you're not on the axes, each one of these, if you drop a right, to find the x and the y coordinate, we would drop a perpendicular there, and this is our y and this is our x. Notice over here, if I drop a perpendicular, let's say 5 pi, 6, 7 pi over 6 right here. If I drop a perpendicular to the x-axis, I get my y and my x, and in each case we have a 30-60. So let's draw the one that we should have memorized. A 30-60, or a pi over 6, pi over 3. The short side is 1/2. The long side is the square root of 3 over 2. Hypotenuse is 1. This is pi over 6, and the larger angle is pi over 3. So let's do it. Let's just use that one triangle. This is all you have to know, other than where those angles are on the unit circle, which once you figure it out yourself, it's nothing. So it's so easy. Let's find the sine of 5 pi over 6. Well, I wouldn't have this all drawn out, the unit circle. I would just draw my own little thing, and I'd go 1, 2, 3, 4, 5. There it is. And I know that this is 1/2, and the x-coordinate would be minus the square root of 3 over 2 because it's in quadrant 2. So the sine of 5 pi over 6 is 1/2, and the cosine of 5 pi over 6 is equal to negative square root of 3 over 2. Well, how about the cosine of minus pi over 3? Well, I think of that as the cosine of minus 2 pi over 6. I just count around my little pi over 6's, and I would draw my little axes here, and I go in this direction because it's negative, and I go 1, 2 of them. There is my triangle. I want the cosine, the x-coordinate, that's the short side, 1/2. So it's equal to 1/2. And that's how you do it. If I have multiples of pi over 3, I just change them to pi over 6's and count off in the right direction how many there are. I see where I land, and do I want 1/2 or the square root of 3 over 2, and is it positive or negative? That's all you have to do. So let's see. Okay, so let's do these. You know that tangent and secant and cosecant are all defined in terms of sine and cosine. Tangent is sine over cosine. Opposite over adjacent is probably how you learned it, sine over cosine. So what I do first is I just draw my little thing, and I try my little axes, and I try to find out where I'm going to end up at minus pi over 4. Going clockwise, just 1 pi over 4, draw the perpendicular to the x-axis. It's a 45, 45. Now, the tangent, let's label this point. The point will have positive square root of 2 over 2 and minus the square root of 2 over 2 because y is negative on the unit circle in quadrant 4. So the tangent is sine over cosine. So you can see it's going to be minus 1. Now the secant is 1 over cosine, so 5 pi over 3. I have to see where I land up. 5 pi where I land, 5 pi over 3. I think of it as 10 pi over 6. So I just go in this direction. 10 pi over 6 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here. And I get one of my 30/60s. I want secant, which is 1 over cosine, and the coordinates of that point are, well, the x-coordinate is plus 1/2, the y-coordinate is negative, square root of minus the square root of 3 over 2. Secant is 1 over cosine. The reciprocal of 1/2 is 2. Cosecant is the reciprocal of sine, 2 pi over 3. Well, again, I'm going to think of it in terms of pi over 6's. Minus 4 pi over 6. I'm going in this direction. It's negative. 1, 2, 3, 4. So I end up here. Drop my perpendicular to the x-axis. This point then has coordinate negative 1/2 for x, and for y minus the square root of 3 over 2. X and y are both negative in quadrant 3. So cosecant is the reciprocal of sine, so it's going to be minus 2 over the square root of 3. So that's it. I think you could find all of the trig functions. You just have to know how they're defined and how you get sine and cosine off of the unit circles.
I found this short video illustrating how the sine curve in the usual rectangular coordinates is made or generated by what we just learned about the unit circle. This is in Mathematica, by the way. Take note that the angle for which the terminal side intersects the unit circle in the point cosine theta, sine theta, the angle is on the horizontal axis. Notice pi over 4, pi over 2, etc. That's the angle. And the vertical axis has on it the y-coordinates, which are the second coordinates of the points on the unit circle.
If an angle is in standard position, the point where the terminal side of the angle intersects the unit circle will give us both the cosine function value and the sine function value, where the x-coordinate is the cosine function value and the y-coordinate is the sine function value. So we're going to animate this point around the unit circle, and when we do this, we'll plot the y-coordinate or the sine function value on the coordinate plane for the angles from 0 to 2 pi radians. So notice at 0, the sine function value is equal to 0. Then as it approaches pi over 2 radians, the sine function value approaches positive 1. So it's increasing now. And then at pi over 2, it reaches a value of 1. And then from pi over 2 to pi, it decreases back to 0. And then from pi to 3 pi over 2, it continues to decrease to a function value of negative 1. And then from 3 pi over 2 to 2 pi, it increases back to a function value of 0. And that's one period of the sine function. As we continue to rotate around the unit circle, this graph would repeat itself. Let's take a look at that one more time. So the sine function value starts at 0, increases to 1, decreases to 0, and then decreases to negative 1, and then increases back to 0. All of these sine function values came from the y-coordinates of points on the unit circle.